process used for production of gas from coal in Dunedin was the Woodall-Duckham continuous vertical retort system. The introduction of this process, patented in 1903, had a profound effect on the gas industry throughout the world. The first plant was the experimental retort at the Bourne Valley Works at the Bournemouth Gas and Water Company, followed by 2 further experimental plants. The first successful commercial contract was at the Bourne Valley Works for 16 continuously operating vertical retorts capable of carbonising 40 tonnes of coal per day in 1906. At the peak of the industry, before it was overtaken by natural gas, over 500 such plants existed throughout the world. The introduction of the process was significant for both owners and operators. Coal carbonisation was significantly more efficient and working conditions were greatly improved. The continuous vertical retort is a sealed refractory brick retort in which coal is heated and carbonised as it slowly and continuously descends within the retort. The gases and volatile byproducts are driven from the coal during the descent and taken away from the top of the retort, whilst the residual coke is extracted from the bottom. The speed of coal feed and descent is automatically controlled by the rate of coke extraction, which can be adjusted to suit the type of coal. The heat in the coke in the lower portion of the retort is utilised for producing water gas, mainly hydrogen and carbon monoxide, by admitting steam through the extractor box so that it reacts with the incandescent coke. The amount of steam determines the calorific value of the mixture of coal gas and water gas leaving the top of the retort via the gas offtake. The coal is finally quenched with water, sprayed within the extractor box and is discharged cool without flame or smoke. The retorts are built in benches, that is, groups of retorts contained within a steel structure. A bench may comprise as few as 3 retorts in a single line or as many as 32 arranged in a double line. The Dunedin Gasworks used 20 in a double line. The retorts are heated by the Lambent heated system, wherein producer gas is burnt in specially designed heating flues on each side of the retort. The producer gas, which is generated in a step-grate producer, is obtained by gasifying a portion of the coke extracted from the retort. The gas which is taken off the tops of the retorts is known as foul and undergoes a series of purifying processes in which water vapour, tars, hydrogen sulfide and other impurities are removed before the gas is stored in water-sealed gas holders and then distributed to consumers. Another important byproduct of the gasworks is coke, the carboniferous residue of coal after the volatiles have been boiled off. Coal for the Dunedin Gasworks is shipped from mines in the Buller and Greymouth areas, coals long known for their suitability for gas production. It's transported by rail and arrives at the gasworks in open wagons. Unloading is by a grab bucket on a Telfer traversing crane, and the coal is then sorted and stored in bins dependent on its swelling characteristics. When required for use, a suitable mixture is chosen, put in a blender for mixing, and then elevated to overhead hoppers. Coal is then loaded onto a motor truck, which proceeds to the weighbridge for exact weighing essential for charging the retorts.
This one going up the retort house? Yeah. Okay, last one.
The truck then proceeds to the retort house and tips coal into the screen at ground level, loading the elevator hopper. The lip bucket elevator then carries the coal along under the retorts and up the northern wall to the very top of the retort house, where buckets are mechanically tripped to empty their contents into hoppers. There's also a coke hopper, in which some of the coke byproduct of the process is also elevated for use in the initial charging of the retorts. The retorts are heated by producer gas, generated in step-grate producers at the bottom of the retort house. These are charged with coke, burnt in the presence of a controlled amount of air, which produces carbon monoxide, channeled through necks, each of which feed a bed of 4 retorts and produce temperatures around the outside of about 1500 degrees Celsius. The heat is then collected by a waste gas main and then channeled through a waste heat boiler, which produces steam for other parts of the process. The retorts are charged from the hoppers above, first with coke and once they are up to temperature with coal. The temperature in the retorts reaches 1000 degrees in the centre, although varies substantially at different levels. Steam is injected into the lower part, and in here the water gas reaction, that is, water plus carbon producing hydrogen and carbon monoxide, takes place, which provides one component of the final product. Gas permeates up through the charge and is taken from the top by a collecting main, cooled by water sprays and then sucked by a vacuum created by extractor pumps elsewhere along a foul gas main to the weir in which water vapour condenses out, as well as providing a seal. From this point, the gas is extracted from the retort house for further processing. Whilst gas is extracted by the suction created by exhauster pumps and sent for further processing, there are 2 other main byproducts. The most important is coke, which is gradually extracted with a continuous and even movement using mechanical extractors which have helical teeth and constantly feed coke from the bottom of the retorts to mobile hoppers, from where it is removed for sale to consumers, used in charging the retorts, and for the production of producer gas. Gas from the exhauster house is pumped to the electrostatic detarer, which operates at 33,000 volts DC, from here to the ammonia scrubber and then to the purifiers. These contain ferrous oxide mixed with wood shavings to increase their surface area and to remove hydrogen sulfide. From here, the gas is measured at the station meter and then is stored in gas holders. Tar is extracted at several stages of the process. In the retort house, it condenses out in the weir and at low points of the pipeline, as well as in the condensers, the electrostatic detarer and the purifiers. From here, it is all drained to the tar well and then periodically pumped to the tar plant from where it is distributed for use by consumers. The mode of power for exhausting of the raw coal gas from the retorts requires low pressure pumps, and this is achieved by the use of traditional horizontal steam engines running at slow revolutions and directly coupled to vane type rotary exhauster pumps. These engines also provide enough pressure to enable the gas to be stored in water-sealed gas holders, which provide a substantial reserve to accommodate changes in demand on the distribution system. Steam is provided by a traditional underfired multi-tubular boiler fired with coke. As well as a modern package-type boiler burning oil. Gas is moved through the mains around Dunedin by the pressure of the gas in the gas holders. However, when high demand requires a boost, this is provided by a steam pump. Final control of pressures in the gas mains around Dunedin is achieved by the use of water-sealed governors, the design and function of which is essentially unchanged since last century and hard to improve on.